Hi everyone, in this video we will cover section 3.2, domain and range. Let's start talking about what domain and range are. Domain is really telling us where the x values are going on a function. Okay. Um, and specifically, it's all the possible values of x. Not in the whole entire world, but in the context of that specific problem. Similarly, range then is where all the y values go. So all possible values of y in a function. Okay. So for example, we have this set of coordinates, okay, 210, 310, 420, 530, and 640. The domain is literally the x values. So we would say 2, 3, 4, 5, and 6. We wouldn't say 2 through 6 because that would insinuate 2.5 is part of it, or 3.1 is part of the domain, or 5.7 is part of the domain. That's not what we're being told. We're simply being told that these are the coordinates, and so that means those are the values of our domain. Okay? In order to identify your domain for an equation, you need to figure out if there's any restrictions. So there's several types of equations that have restrictions. Fractions have restrictions, and roots have restrictions. Okay? Quadratics, like this next example, do not, which means that the domain is negative infinity to infinity. Okay? That's also known as all real numbers, which can be written like this. Okay? You could write negative to positive infinity, or you could write the all real numbers symbol. Either one is totally fine. So notice in bold here at the bottom, if there's a denominator in the function formula, set the denominator equal to 0 and solve for x. That is the number that the domain would skip. Okay? Denominators can never equal 0. If there's a root, set it greater than or equal to 0 and solve. Roots can't be negative, so there's your restriction for roots. Let's briefly chat about interval notation. Okay, interval notation is when we write our solution using parentheses, brackets, infinity symbols, similar to what I wrote earlier with negative to positive infinity. So right here, I'm saying that my answer is between 4 and 12, including 12, but not including 4. So this says my answer is from 4 to 12, including 12, excluding 10. Parentheses are used when we are not including a value. So let me make a little table here for us. If we are including, we will use brackets or maybe a closed circle on a graph. If we are excluding, we will use parentheses or an open circle on a graph. Let's find the domain and range of the following functions. Keep in mind, this is a quadratic. So its domain is negative infinity to positive infinity, no restrictions, which means for the range, we have to find the minimum. That can be found using a graphing calculator in this case. It does allow us to do that. So in this case, our minimum is negative 12.25, and it does go up forever. Looking at a cubic function, now would be a good time to go back and look at our earlier table and say, okay, what's happening with the cubic function? So before we move forward, let's take a moment and write down the domain and range for these functions. I'm going to start with the absolute value. Constant and identity are straightforward. So the domain for the absolute value function is negative infinity to infinity. The range is 0 to infinity. As discussed earlier, the domain for a quadratic, negative infinity to infinity. The range is 0 to infinity for the parent function. Obviously, the range can change if the function moves up and down. Domain and range for the cubic function is negative to positive infinity. Domain and range for the reciprocal function is negative infinity to 0, skipping over 0, picking back up after 0, and continuing to infinity. You'll notice that we never approach 0 from any side, which means we're going to skip over it. It's called an asymptote. We'll cover them more on later sections. All that you need to know right now is that it doesn't touch the 0. Then we have the square root function. The square root function starts at 0. This is theoretically a closed circle. The figure doesn't really do a good job showing that. So we start at 0 and go to infinity. And range is the same. Start at 0, go to infinity. Cube root function, similar to the cubic function, domain and range are negative infinity to infinity. And for the reciprocal squared, domain is negative infinity approaching 0, skipping over 0, picking up after it, whereas range is 0 to infinity, not including the 0. Again, we will never touch this, and so we start at 0, but not including it. As mentioned earlier in 3.1, these are super, super important. It is worth taking the time to really understand these because they are going to be coming back. Now let's finish working through these. The second one is going to be a cubic function, which tells us domain and range are going to be negative infinity to infinity. The next one is a root, which tells us it must be greater than or equal to 0. So let's go ahead and solve. Move this over here. And we have x is greater than or equal to negative 3. In my proper notation, that's going to look like this. Okay. With my range, it's going to be from 0 to infinity. You can confirm that on a graphing calculator, but I know that I have not shifted the function up or down, so that doesn't change. My next one, let me move it over here, is x over x minus 3. So what's happening here is I can't have a denominator equal to 0. So I'm going to go ahead and solve and find out that x can't equal 3. So my domain is going to be all numbers except for 3. I'm going to approach 3 and skip over 3. On the graphing calculator, you'll find out that the range skips over 1. in later sections, we will talk about how to find the range algebraically. For now, I'm more concerned about finding the domain algebraically than the range. Okay. Then we have the last one. Not only can it not be negative, it also can't be zero. So in this case, we are going to set this to greater than 0 instead of greater than equal to. So we can't have a denominator of 0. So in this case, x is going to be greater than 4, or we could say 4 to infinity is your domain. Whoops. Here we go. All right. That covers finding domain and range for a couple different types of functions. Again, I really encourage you to familiarize yourself with those parent functions. They are really, really useful. Now let's find domain from a graph. Okay. From a graph, you are just going to look and see how far the domain goes from left to right, and then you'll repeat that process for the range going low to high. So here, notice that we start at 3, but it's an open circle, and we go as far as 1, and it's closed. For range, notice we start at -4 and go as high as 0. Here it is included, so I'll go ahead and put that 0 in a bracket. We also have piecewise functions. So those are literally pieces of functions that are getting graphed. Okay, so let's just go ahead and look at this next one. You'll notice that it has 3 different functions written together as one. Theoretically, this should be written like this, but we can't write it like that in a document. It doesn't let us write it like that. So we write them as f of x. So the first one exists, excuse me, when x is less than or equal to 0, right here. The second one exists between 0 and 2, and the third one exists at greater than 2. That's really important because right here it says find f of some number. That number is going to tell you which function you're working with. If I'm looking for the first one, f of -3, only one of those functions exists when x is -3. It's the first one because that's where x is less than or equal to 0. That's going to get me -3 squared, okay? And that's going to get me a 9. Okay, when I plug in 0, that's still the first one because it's less than or equal to 0, and I'm going to get 0. When I plug in 1, that's going to be my second equation, and I'm going to get 4. When I plug in 2, that's the second one because of the equal sign. And when I plug in 5, that's the last one, and I still get a 4. Okay, it's really important to recognize which function you're working with because they only exist in certain areas. Now, the last part. We can actually graph a piecewise function. It's going to require you to do it in parts. My suggestion is start with your domain. It's telling you where the function exists. So here, I exist at less than or equal to 0. So I'm going to plug in 2 points. I'm going to plug in 0, and I'm going to plug in -1, and we'll see what I get. So when x is 0, I have -0 minus 1, which is -1. When x is -1, I end up with 0. So I have this coordinate and this coordinate. It said x is equal to 0, so this is a closed circle, and so is this. So 0, -1, and negative 1, 0. I am moving to the left because x is getting smaller. So there's my first function. Move that there. Then I have to repeat that process with my next value. Now I have x is greater than 0. I'm not including 0, but I need to start there, and I can represent not including it with an open circle. So I'll go ahead and say x is 0 and x is 1. That's going to be 1/2 times 0 plus 2, and 1/2 times 1 plus 2. So I have the coordinate 0, 2, and 1, 2.5. This is an open circle because we are not including 0. This is a closed circle. I'm going to go ahead and plot that. There's my open circle. There's my closed circle. And I can go ahead and draw that line. This is what the piecewise function would look like. Now, keep in mind you have the option of plugging in whatever numbers you want as long as they're within the domain and one of the numbers is where you're starting. We're starting at 0, regardless of the first one or the second one. The second one simply doesn't include 0, but you still have to start there and show that it's not included with the open circle. That is really, really important. Do not start at 1, because if you start at 1, you're skipping over all the numbers between 0 and 1, and we don't want to do that. Let's do the second one. In the second one, you're going to find that you end up with a quadratic. Anything that's not linear, you need to plug in more than 2 points because it has a curve. If you only plug in 2 points, you don't know what the curve looks like. So for the very first one, let's go ahead and pick 3 points. I'll go ahead and do 0, negative 1, and negative 2. So I'll make that green. Okay, I'm going to plug each of those things in, and I'm going to get a y value. 0 squared is 0. Whoops. Negative 1 squared is 1. Negative 2 squared is 4. So here are my coordinates. 0, 0, negative 1, 1, negative 2, 4. All of them are closed. Okay, and I can go ahead and plot those points. 0, 0, whoops. Negative 1, 1, and negative 2, 4. Notice that that third point shows my curvature. That is important. The next function, which I'll do in pink, has a sectioned domain. It starts at 0 and finishes at 2. So that's what I'm going to do. I'm going to start it at 0, and then I'll plug in when it's 2, and I can solve for those. Notice that it's just a value of 4. So no matter what I plug in, my output is a 4. So 0, 4, and 2, 4. The 0, 4 is open because there's no equal sign here, and the 2 is closed. That's all I need to do for the second function. So now I have 0, 4. Oops, that's open. And 2, 4. And a line connecting them. Finally, I have my last one, which I'll do in blue. It's greater than 2. It is linear, so I'll go ahead and say 2 and 3 and go ahead and plug it in. Sorry guys, my screen keeps shifting. equals 2 minus 1, which is 1, 3 minus 1, which is 2. So I have 2, 1, and 3, 2. Open circle at 2, close circle at 3, because now it's bigger than 2. So 2, 1, 3, 2, draw the arrow. That is going to be your second piecewise function from start to finish. Okay. Again, it is important to pay attention to the symbols in your domain. The symbols determine open versus closed. Once your number is larger or smaller than your restriction, you're all set to do a closed circle. Okay. If you're starting when it's open, make sure you're still plugging in that value. That's an important value. You have to start with the 2 in the blue section. You have to start with 0 in the pink section. Okay. All right, that covers it for 3.2.